SwayamPrabha. Digital India. Educated India.
Good morning. Welcome to the NPTEL online course on the architecture, structural system in architecture. We are in the module number 6, that is the 6th week, and today we will be discussing about the structural principles and application of arch, which is a lecture number 27. If you remember in the earlier lecture, in the first lecture of the week number 6, we have classified the arch, and we have noticed that the what are the different type of arch and what are the different the component of the arch. Today we will basically go into the structural component of it, the principles that arch is going to behave, and we will understand some of the arch action from that point of view. After we understand the action point of view, the arch principle, the structural principle, we will try to analyze the arch, and then we will another very important thing we will going to discuss, that is the concept of thrust line in the arch. So, our learning objective of the course will be we will illustrate the structural principle as I told, and we will going to analyze the circular arch and the parabolic arch of 2 hinge and the parabolic arch basically of the fixed type of arch also we will going to discuss. And at the end we will be going to outline the stability consideration of the arch through the thrust line concept, and this stability of the arch will be discussed from the masonry arch point of view. So, let us start the first action of the structural properties of the arch from the point of view of a structural system. So, in the first the left hand side figure I have drawn a cable, in fact 2 cable and under a weight, and when this 2 cable is under a particular weight, you see from the external load if it is applied at the point. So, this cable will be in a sagging position and the tension will be created, tensile force or the tension will be created in the cable. If I reverse the position or the reverse the total scenario, the force application, I will get the second or the right hand side the figure, where it may not cable is not possible in that kind of form, but suppose there is too rigid the object and that create a kind of a triangulation, and there is a force which is applied on the tip of that particular triangle, and because of this particular triangular force or triangular system and the force, there will be a compression will be create in the particular component, both the component. So, that is the difference between the cable and arch. Cable is always going to be a sagging kind of a nature, whereas arch is a triangular kind of a nature, where there is a tip or the crown is at the top. Next, let us see some of the historical example where there are triangular arch has been created. So, if you see a pyramid of Giza, the Great Pyramid of Giza, which was built long back 2516 BC. In that, if you see the king's chamber and also if you see the queen's chamber, which is smaller, those two portion, also the grand gallery and this portion, grand gallery portion and all, those are the empty things. There are nothing, no support, there are mummy and all those kind of things are placed over there. So, that is the empty, that is a vacuum kind of a thing. But it has enormous amount of weight due to the stone blocks. So, what happened is that in this particular in that particular system, if you go to the queen's chamber, You see this Queen's chamber is created by two such stone pieces, big stone pieces, which is triangular in nature. This triangle formation are also in the King's chamber. There are two pieces which going to have a triangular in nature. By virtue of the external load, this triangular system of the stones will create a arch action, and it can support the volume inside. This total volume inside can be supported by that load. Please imagine that over that there are huge amount of load, which is solid rock pieces has been actually applied as external load. So, since that time we understand the basic principle of that art. The engineers of that time, the Egyptian civilization, they also understand the basic nature of the profile or triangular profile of that, and that can hold a lot of amount of pressure. But how that is going to hold, I will going to discuss in the next slide. Even if I come down to some other type of nature of the arch, which is another historical nature, we may say as it is a corbel arch. The corbel arch is developed like corbelling of different type. I mean it is something like a brick, something like a one piece of stone, and the second piece of stone is arranged like this, and the third piece of stone is arranged like this. Something like this has been arranged such a way that it can create a kind of a opening, and as and when it create a opening, it is very important to see how much is the distance, and this is given as a 1/4 to the 1/4 to 1/3 of the distance cantilevering out from the one block to the other block. So, in this particular case, I have a small video, and this video I will just like to show you, that is how this particular corbelling will be going to occur in this particular manner. See, this is a block. This block is going to have that particular and the third block is now placing over that, and this is going to have a kind of a unstable kind of a effect. And when the blocks are arranged in a such a way that that particular cantilevering is done properly, the relation between one to other, this particular thing will create a kind of stability in that particular formation of the arch. So, in this case a corbelling can be done in the various manners. So, here the two examples of the corbel arch is given over here. One is the Barabadur, that is in the Java, the temple where there are some stone pieces which creates a cantilevering out kind of a thing, and there is a kind of a projections out of it. And there is another temple in our country, that is the Konark temple, the Sun temple at Konark. So, here also in the very entrance gate you see there is a kind of a corbelling can be done. So, in that corbelling arch can be derived from the horizontal post and horizontal lintel kind of a thing, but that is having some kind of a problem. It can actually going to break because of the huge amount of load, and because of that a corbel arch, which is a triangular formation, has been created. We have seen in the temple, or we can see as a altogether a flash kind of a triangular piece of stone in pyramid of Giza. And from the corbel we can go to the some kind of the semicircular arch, which is also kind of a invert kind of a nature. So, I have another video for just to justify the action of the arch. Before we go to the explaining the action of this particular thing, arch action, we will try to visit this particular second video on arch. Let us see this particular video, and you see somebody is one of our research scholars is pressing that particular arch, and it is separating out from the blue line. Okay. So, if you revisit the video, so it started from here initially, but when the load is applied of this particular from this particular point, it is sliding outward, sliding, you see, sliding outward, right. It started from this green line, mark line, and now it is actually sliding outward, and this will be is going to be the first kind of action what we can think of in the particular arch, or this kind of arch action. So, under the load, under the downward load, the legs of the arch is going to spread outward, something like it is going to spread in other way. So, to establish the equilibrium along with this particular vertical reaction, there is a horizontal reaction has to be exist. What does it mean? It means if there is external load in a particular arch, a load will create a horizontal reaction, and this horizontal reaction is necessary to, otherwise what will going to happen, it will be unstable because it will leg will go apart. Vertical reactions is also there because V A plus V B must be equal to your this external loading P, but there will be some horizontal reactions are also has to be there, and due to this horizontal reaction there are arch action or the systematic arch action will take place. So, in this particular slide I have shown you a arch, a typical semicircular arch, and the external load is given, and due to the external load there are horizontal reaction and the vertical reaction. Vertical reaction is obviously there, horizontal reaction is taken care of because there is a arch action which is try to separate the legs, but it is not because of some kind of a embankment or the pier. So, this P is now can be divided into two component which is marked as C and C. Okay. So, C and C are the two component. Why C I will going to tell you afterwards. So, C is the component for the external load in the two direction of the arch, and also this H and V will give you a resultant R over there. So, now you see the line of action of R and C, which will be presented in this whole portion, also in this whole portion, because there is also a H, there is also a V, and so there is a R. And this particular R and C, this is the component C and the component R, reaction component R, will create a compression hole. So, those hole versus and everything will be under a pure compression because the virtue of the R and this R. So, what happened? P break down to the two C's, and this horizontal and vertical is a derivative of this P, create a R direction of R and direction of this component C create a compression. So, under the gravity load the arch is come under the pure compression. So, brittle material like stone, brittle material like brick will be very good, as you know that it is very good in the compression, brittle materials are in very good in compression. So, you can easily use the brittle material like stone and all those in our criteria, in our case of our in case of our the arch stabilities also. So, we will again give you another good example where we can use that particular concept and see the how a egg can be break. Suppose this is a egg, and I want to break this particular egg by some external load. So, if I put external load on the top of that particular egg, because of the it is a arch kind of a surface, or this is the arch kind of a nature, shell of the egg is the arch kind of a nature, or the profile is the arch, it will create an arch action, which is just now we have seen it will give a reaction and it will give a kind of a the component of the external load, and that will going to have the compression inside. And as it is compression inside, arch action will create a compression in the shell, in the thin shell, and as you know this thin shell is very good in compression because it is a brittle material. So, it can resist the compressive stress very easily, and it will not going to break easily. It is very difficult for break. I mean, you have to create the additional amount of pressure and you have to break it, because the shell, that kind of a shell eggshell is very good in the it is a brittle material, compression it is very good, it can hold lot of compression. So, tough to break the egg by external load. So, you have to put some extra amount of effort to break that particular thing. But now, see the reverse action. Reverse action is that suppose you have same egg and you are somehow put something inside and you are putting the pressure upward instead of the external pressure, internal upward pressure. So, what will be the arch action? Now, the reactions component and the component of the external load, which is the internal pressure, will be reverse. And as and when it is reverse, see these two are going to have a tensile kind of action. So, if you put the external load, so suppose you are putting something from the behind below, push something in a scissors and all those kind of a thing, then you will create a kind of the tension. And as in when you create a tension, the brittle material, eggshell is a brittle material, is very weak in tension, it is very strong in its compression, but very weak in tension. So, as it is very weak in tension, tensile stress, it can be break, very easily you can break it, and because of this kind of a break, it is easy to break the egg from the internal small pressure, and that is why a chick which is just newborn chick with a very small pressure can actually come out from the egg. So, it will going to give you a kind of understanding that how the arch action is creating and how the arch action from the external load point of view, downward gravity external load point of view, it is creating a compression throughout, and that is why we use the we can use actually you can allowed to use the lot of the brittle material like the stones and bricks as a arch material for the arch, and it is historically we have been doing such for a long time since the period of the Giza and the Egyptian architecture. Now, another type of the arch action, let us understand the why the arch action is important and the beneficial to us. I have taken an example of a beam, hinged, simply supported beam, and a load is placed at a distance d from the one end. So, the bending moment at particular point x is given by this formula V into x minus P into x minus d, which I called as a MBX because it is a section at x. So, the moment at x for the beam, it is a case of a beam. Now, see what is the case of a arch. One important thing you must have noticed that in this particular beam you do not have any kind of horizontal direction, that is missing because it is straight in nature. Horizontal direction will come whenever there is a profile is a arch profile, because if you imagine now we have seen the video that it is an arch, then if you push it, it is spreading the leg, but if you take a straight bar like this, if you put a load, it cannot extend it. So, there is no question of any horizontal reaction. So, in the arch the horizontal reaction is exist. So, we have a VA, we have a HA also, and this load is still there, and because of that the moment due to the arch at x, this A stands for arch, is Vm into x minus P into x minus d. So, this distance is x minus d into Px, and also minus h into this y, because h and y is also creating a moment, particular moment over here. See, this is the load and this is the perpendicular distance from the load, that is y h into y, that is h a into y. This is extra thing came in the arch. And what is this? This is the beam moment which we have discussed in the earlier slide, V A into x minus P into x minus d. So, that means the arch moment is beam moment minus something. So, that means the arch moment is always less than, will be the less than beam moment if you compare with the same span or whatever. So, that means what? That is always the arch will give you a less amount of moment with respect to beam. So, as it is experiencing less amount of moment, it will be giving you less amount of reinforcement, less amount of concrete area, less amount of the thickness and the geometrical property of that. So, for a same span, it is better to cover with a arch instead of a beam. If the span is higher, we can save lot of material, lot of reinforcement and all. So, that is why the action of the arch, because of this HA, is creating a compression all through and also reducing the amount of moment with compared to the beam moment. So, let us now go to the next chapter, which is the analysis of the arch. So, we will do the analysis of the discuss the analysis of the arch for the both the semicircular arch and also for the parabolic arch. In the semicircular arch, it is a two hinge semicircular arch, and there is a point load is applied over here at a point, certain point, which is marked as angle theta from the center. So, as I have computed the R A and R B's, the H will be this. The derivation of the H is beyond our scope of discussion. So, let us assume that P by pi into sigma square alpha is the horizontal reaction. It is depend upon the angle alpha, it is depend upon the P also, and because of this particular this particular action of the load, I have computed the what is the value of V A and what is the value of V V. These both has been computed by taking moment about A. If you take the moment about A, you will get the V A. If you take the moment about B, you will get the V V. So, this all these things are explained through this particular slide, the distances and all. So, this is the V A and V V. For any load which is a eccentric load at a certain distance, but certain distance I am measuring from the angle from the center. So, in case of the it is a central load, suppose it is a very central load, this load is here now, then I can have the rewrite the equation just putting the alpha equal to 90 degree. So, sin 90 is 1, so it is P by pi and V A and V B equal to P by 2 P by 2. But now, if I have the UDL, the uniform distributed load over the arch, then this will be the total amount of reaction, because total load will be your W into 2 of R, because this is the total length is the diameter of 2R, this is 2R. So, the total load is W into 2R and each reaction will be just half of that. So, this is W into R. Whereas, the horizontal reaction will be 4 W R by 3 pi, which again beyond our scope of that requires some kind of the integral equations and all. So, that is beyond our scope. Now, let us go to the parabolic arch. Before we go to the explanation of the action of the parabolic arch, let us see what should be the equation of the parabola, which is very much important, because I need to know the height y with respect to the sliding from this, if this is the origin, I need to know what will be the height at any distance x. Okay. So, for that the equation of this parabola will be this: y equal to 4h by L square into L minus x into x, and then if I just put L equal to x equal to 0 or L, whatever may be 0, x equal to 0 is this point, because this is the origin, and x equal to L is this point B, which is again the another extreme part. In the both the cases, if you put the x equal to 0 and x equal to L, you will get y equal to 0, and that has to be that, because the no elevation at this particular 2 point. Whereas, if you put the x equal to L by 2, that means x equal to L by 2 at the middle point at this point. So, if you just put x equal to L by 2, x equal to L by 2, you will find that y equal to h. That means, at the middle point this height is equal to h, and which is true also. This is the rise of the arch, this is the rise of the arch, and this is the span of the arch. So, this equation holds good for all these 3 points. So, it will also hold good for all the internal points. Now, you see a fixed parabolic arch is under a concentrated load at a distance d, and I have taken out this particular the equations and all these things from the book, and I have verified also, and these are the horizontal reactions H A and H B. These are the vertical reactions of V A and V B, which is there are comes with a factor of L is there, the D is there, as which distance is there, the P is there. These 3 are the basic parameter of that, and of course, the h is also having a particular value h also, that is the height or the rise of the arch. Similarly, we can use, as it is a kind of the fixed arch. So, these 2 are the fixed. So, it will have some kind of a moment also. This moment can be also taken into this the formula, which are look little big formula and some complicated formula, and we can also find out the MA, the moment at A and moment at B and the moment at C, that is at the crown point, that is at the center point of that particular thing. So, those 3 points and those 3 moments can be calculated by virtue of this equation, and if you want to put the point this P as at this particular point, the load at this crown. So, D will be your then L by 2, and you can replace the D by L by 2 and you can rewrite the equations and find out the what are the values. So, similarly, we can have the L by 2 case also, whatever we have discussed, and you can find out the changes, and thus that very complicated equations now become very simple. The MA and MB equal to PL by 32. So, these moments of PL by 32. The moment at C will be something like PL by 3 PL by 64 or like that. HA and HB will be like 15 PL by 16 H. Again this H is your this rise, and V and VB equal to just as simple as P by 2 P by 2. Now, if it is parabolic arch is under the UDL, so uniform distributed load. So, the VA and VB equal to WL by 2, that is the total load is W into L, W is the total this load and the L is the length. So, WL, and that will be divided equally to 2, and the horizontal reactions will be WL square by 8 H. So, that is the horizontal reactions, these two will be equal and opposite, and the moments at x I have found out at x distance what is the moment. So, that is WL by 2, this WL by 2 into x minus due to this load W into x by 2, that is the W x square by 2, that is negative and this is positive, and also this H will also give you a negative sign because this is the reactions W L square by 8 H into y, y is this. Now, if I put the values of all those y, the replace the value of y, this is the equation of the parabola 4 H L square by L minus x into x, and if I again rewrite this, and it will come like this, and finally, it will become like this. You can recalculate and check, and if it is like that, you see the interesting thing is that like a magic, it will come like all everything will get cancelled. Okay, this will get cancelled by this one, and this will be cancelled by this one. So, finally, the Mx equal to 0. What that is mean? This means a lot. This is a means a lot to us. That means, if it is a parabolic arch and if it is under a UDL, at x distance it will experience no moment. That means, anywhere in the arch, even from this point of contact to this point of contact, any distance of x, here, any distance, it will not going to experience any kind of moment. This is very important. And another thing we will understand from here, this H by B, this horizontal thrust, horizontal reactions will increase due to W increase, due to L increase, the length increase, the span increase and the load increase, but it will decrease if H increase. So, if you take a parabolic arch like that and if you take a parabolic arch like that, this will give you a less amount of H, but this may give you a high amount of H. That is also very interesting from this particular thing. So, we have to see that as and when the parabolic arch has a high amount of rise, that is the H, it experience less amount of horizontal thrust and no question of any kind of a moment. So, we will now go to the concept of thrust line. A thrust is generated by two wedge actions. So, there is a weight of a wedge washers and this is another horizontal thrust and it has a resultant. So, that is the thrust. So, the thrust is generated by the virtue of the weight of the wedge and the horizontal thrust, because one will give you the thrust to the other. So, in this particular platform, if I have arranged this wedge in this circular manner, each washers will be provided the horizontal thrust and the weight, and finally, each will have this kind of a weight which is downward in nature. Each wedge will give you a horizontal thrust which will be this side, and finally, these two will have the resultant, which is red in color I have shown, depending upon the nature of the wedge or the weight and the horizontal thrust. And now, if you make a imaginary line, which line is a tangential to this particular line, thrust line, thrust will be called as a line of thrust. So, this thrust line. So, what we will understand from here is that as long as this thrust line are in between the middle 1/3 distance. So, this distance, this pink color or whatever color is there, in central 1/3 distance, the arch is very stable. So, the thrust line may come like this, or the maximum possible it may go like that inside the arch, but we should take care the arrangement and the length and this particular rise such a way that it should go inside the 1/3 kind of a thing. Okay. So, that is if now if the LT, that is the LT is the thrust line, goes the inner third line, inner side, then this it will going to burst outside. And if it goes outer 1/3 line, so that somehow, so it will going to collapse inside the inside. So, this is very important. So, if it is goes outside, it will break outside if it is the thrust line is inside, and if it is outside, then it is going to break in the outside. So, I have taken the reference of those books, and this is the conclusion, and the arch is a very special type of structure, as you know, and this is a due to the parabolic profile, it gives you lot of wonderful things from the structural point of view, which help us for the material savings and all. From the stability point of view, arch line or the thrust line has to be taken into account. So, I have given 3 homework for that. One, if it is a fixed parabolic arch of span 12 meter and rise 3 meter, and uniform distributed load 10 kilonewton per meter is given. You have to find out the support moment and support reactions and the moment at the 1/3 span, that is 4 meter away from the support. And also I have given another problem is the circular arch is there with r radius and p, the similar formula you can use, and you have to find out the support reaction and the bending moment at the crown, that means at this particular point what is the bending moment. You have to find out that bending moment if the value of p and r is 20 kilonewton and 5 meter respectively. And also the third problem is that suppose this 2 circular arch are actually carrying these 3 beams, which beams are under 12 kilonewton per meter UDL, and these 3 beams are actually finally giving the pointed load to these 3 points like this, and you have to calculate how much is the pointed load, and this position of the beams are 45° radial point, these 2, it is symmetrical and one is in the crown. So, finally, the arch will have the 3 such load P, P, P. This P, P, P are the reaction because of this load, this beam is taking care of 12 kilonewton. So, you have to find out the support reaction and the thrust at the support, and also the bending moment at the crown and under these 2 beams or 2 pointed load at the beams also. So, I think thank you very much for this lecture. We will go to the lecture number 27 with this shell next week, next lecture.